Bienvenidos, Ushamandeed, and welcome Anne Arundel Community College learners from CTS-130, Section 402 for the Spring 2021 semester. This is the Cisco Networking Academy's Introduction to Networks Version 7 course curriculum, and in this tutorial, we are going to be taking a look at IP assignment number 1. Now, we're going to be breaking this down into 4 or 5 different parts so that we can focus on each individual conversion that we're going to be taking a look at. In this video, we're going to be looking at converting binary to decimal. So let's go ahead and dive in and take a look at the activity, and you can see we're going to divide this up into 4 parts, each part focusing on the questions that are grouped together that deal with the conversion that we're interested in. And so here we're going to be converting binary to decimal. Now, one of the first things that we need to talk about when we're talking about binary is that we're going to be dealing with bits. That's B-I-T, and that stands for binary digit. Now, each binary digit has one of 2 values. It is either on, meaning the value is a 1, and therefore the bit position that the bit is in terms of its decimal value would be added into our overall value. The other bit position, or the bit value I should say, is 0. So 1 meaning on, meaning we're going to take into account the value of that bit position in decimal. And the other being 0 being off, meaning we are not going to be looking at that value that corresponds to the bit position in decimal. Now, the way that we calculate our decimal value is again based off whether the bit positions are on or off. Now, we start with the lowest value on the right, and in fact, the last 4 values are referred to as the low order values. And so if we start at the rightmost position, the first bit position, the value in decimal is 1. And then we simply double the value as we move from right to left. Now, for some learners, this is a little tricky because typically when we read from left to right. However, when working with binary and then looking at the decimal value that corresponds to that binary bit position, we go from right to left in terms of lowest decimal value to highest. Now you'll notice that we're dealing with 8 bit positions. Again, the 4 to the right are considered the low order bits, and then the 4 bit positions that we have to the left are considered the high order bit positions. Now, the 4 of these on the left and the 4 on the right, in other words, the high order bit positions and the low order bit positions, all 8 of these together make up what we refer to as an octet. Again, 8, like an octopus, you would say we have an octet. Now, what's interesting is the 4 bit positions on either side, when looked at by themselves, make up what we call a nibble. So 4 bits by themselves are a nibble. 8 bits altogether are an octet. And what this is going to be leading to is our conversation on IP addresses. Because IP addresses and the values that we see in that dotted decimal notation come from the decimal numbers that we see, like a 192, 168, and you can see I'm putting the dot in between, dot 10, dot 2. This dotted decimal notation, again, dotted decimal, meaning we're using decimal values, has a corresponding binary value. And each of these decimal values that we see separated by the dots make up an octet. So 192 as decimal is going to be 8 bits. And again, I'll just put in here 3, 4, 5, 6, 7, 8. And then this decimal value in binary, which is how the computer is going to be dealing with it, is made up of 8 bits as well, an octet. And so we have 8 bits here, and 8 bits here, and 8 bits here, and 8 bits here. Or you could say we have the first octet, the second octet, the third octet, and the fourth octet. And together, those 4 octets give us 32 bits in all. But again, remember, when we're dealing with IPv4 addresses and we're looking at the individual decimal values, each of these decimal values can be converted into binary. And so that's what we're going to be doing over here, is we're going to be converting from binary into decimal, so that we would ultimately, at some point, end up with all 4 of our values. But again, here we're working with what would be a single octet, a single decimal value that will be the result. And so again, from the right-hand side, we start with 1 as the decimal value for the rightmost bit value. And then we double to 2, and then to 4, and then to 8, then to 6, then to 32, 64, and then finally, the final and 8th bit position is 128, has a decimal value of 128. Now remember, we only include the decimal values that we're going to be adding together if and only if the bit position is on, meaning it is a 1. And as we look here, you can see that 4 of the 8-bit positions are on. And what are the decimal values above that correspond to the bit positions below? And so what we see here is we have 64 plus 32, and that's going to give us 96. And then we would add together 4 plus 2, which would give me 6. So then I'm going to add 96 plus 6, and that's going to give me 102. Because again, 6 plus 6 is 12, we carry our 1, and then 9 and 1 is 10. So 102. Now, the bit positions down here, the binary bit positions, don't always need to be next to each other. Any of these 8-bit positions can be on, and any of them can be off. In other words, any of them can be either a 0 or a 1. But in binary, they can only be a 0 or a 1. And again, 1 meaning we then take a look at the corresponding decimal value and add that into our equation that we have up here to then get the result of what the value actually is. And so the value here would be 102. So now let's come down and take a look at this next question, question number 2. Again, we take a look at the binary digits, right? These bits, these binary digits, we identify which bits are on. We then take a look at the corresponding decimal values, and we simply add them into an equation and get our result. So 128 plus 64 is 192. And then I would say plus 8 is going to be 200. And then 200 plus 2, and we don't need to do much for that, is going to be 202. And so then the answer is that this binary representation, 11001010, is in decimal 202. And that's simply how we'll work through the rest of these problems. Now, there's 2 values that are the easiest values that you will ever work with when converting from binary to decimal. And that is the value where all 8 bits the high order 4 bits and then the low order 4 bits are all on. And that value is the highest value that we can see in an IPv4 scenario, which would be 255. So if all of the bits are in the on position, we know right away it's 255 because 128 plus 64 is 192, plus 32 is 224, plus 16 is 240, plus 8 is 248, plus 4 is 252, plus 2 is 254, plus 1 is 255. And then obviously, if you guess that the second easiest one is going to be where all of our bit positions are 0, that will obviously mean that all the bit positions are off. Therefore, none of the decimal values are included in the equation, and we end up with 0. So I'm going to go ahead and clear my screen as we move down and we tackle the next set of binary to decimal conversion questions. And so here we take a look at this next question, question number 3. Again, identify the bit positions that are on, and then identify the corresponding decimal values, and then add those values together. So 32 plus 2, and again, we don't need to do much math here to figure that out. It's going to be 34. We come down to question number 4. Identify the binary bit positions that are on. Identify the decimal values that correspond to those binary bit positions. And again, we're working from left on the lowest decimal value, 1, 2, 4, 8, 16, 32, up to the 8th value of the high order bits. And then we simply add these together. So 32 plus 16 is 48, plus 4 is 52. And so then we come down to question number 5, which has a few more bits that are on here. And so again, you identify the binary bits that are on, those binary digits, the ones we have that are on. We identify the decimal values that correspond to them based on their position, and then we add the decimal values that would correspond to these binary bit positions and get our result. And so 128 and 64 is 192, plus 32 is 224, plus 16 is 240, plus 2 is 242. Now, when you're adding the high order bits going from left to right, and a lot of them are on in succession here, there's numbers that you're going to become very familiar with, like 128 by itself, or if we added in 64, we would get 192, right? So there's that 192, 168. Add 32 to 192, you get 224, another common value that you'll start to see when the first 3 bits are the only bits that are on. If all the high order bits are on, we end up with 240. And so here we go, and then 248, 252, 254, and 255. And so these are values that you will commonly see when you start to work with subnetting. So our answer here would be, again, 242 for the bit positions that are on, and we add their corresponding decimal value based on where that bit position is in this octet. All right, so let's go ahead and clear the screen, and then we'll work our way down to questions 6, 7, and 8. Again, the bit positions that are on, we simply identify those. We then identify the values in decimal that correspond to those bit positions which are on. And then we add these values together. So 64 plus 32 we know is 96. And then 8 plus 4 plus 2, well, it's 12 plus 2 would be 14. And so then we add together 96 and 14. And that's going to give us, if I was to draw it out over here, and again, this one might require you to draw it out. And so we would say 6 plus 4 is 10. So we put the 0, carry the 1, and then we have 9, 10, 11. And so what we end up with is 110. So the binary representation 01101110 is in decimal 110. Again, we ended up with 96 plus 14. Now, down to question number 7. The bit positions that are on are simply 64 plus 8. And so then we add 64 to 8, and that's going to give us 72. Now, down here, we have a few more bit positions that are on that we need to sort out. So we've got 5 bit positions that are on, 128 and 64. We add these guys together, and that's going to give us 192. And then let's add together 16 plus 8, because those bit positions are on. It's going to give me 24. And then we've got 1 down here. So 192 plus 24 plus 1 is going to be the answer that we're looking for. And so we could, again, take this down to 192 and then do the 24 plus 1 and get 25, and then add this together to end up with our result, which is 7, 11, carry our 1, 217. So we end up with 217 for the value of this octet. Again, think of it in terms of an octet. Maybe this is the first octet of 4 octets that make up an IPv4 address. All right, so that's question number 8. So let's clear our screen, and now let's roll down and do the last 2, which are going to be questions 9 and 10. So here in question number 9, again, the process is the same of converting from binary to decimal. We identify the binary bits that are in the on position, identify the corresponding decimal value based on the binary bit position, and then we simply add those values together. So 32 plus 8 is going to be 40. And again, we probably don't need to work this out like this, but just showing you sort of a longhand here, it's going to give us 43. And you'll get to the point where you're able to simply look up here and say, 32 and 8 is 40, and then 2 plus 1 is 3, 43. That's my answer. Again, I'm just kind of showing you the longhand way to do it and the reasoning behind why we're doing it the way that we are. Last question, number 10, identify the binary bit positions that are on. Get the corresponding decimal values that correspond to those binary bit positions in the octet, and then simply, add the numbers together. So here, we'll do it a different way over here. So let's say 16 plus 8 we know is 24, plus 4 would be 28, plus 1, right, would be 29. So we know that 16 and 8 and 4 and 1 is going to be 29. And then we have 128. So we could just bring it over here and say 128 plus 29. And let me, wait a second, 24, 28, yeah, 29. All right, plus 29 is going to be 17. We carry our 1. That gives me a 5. And then we have a 1. So this is going to end up being 157. And I just went about it a different way. Instead of saying, okay, what's 128 plus 16 and then plus 8 plus 4 plus 2, I went ahead and added sort of the lower numbers together and then took the 128 and added the sum of the lower numbers to 128. And that's how we ended up with 157. And again, that's how easy it is to convert from binary to decimal. And so that is going to do it for this first of 4 parts where, again, we're breaking things down so that we're focusing in each video and that you can watch the video you're interested in terms of converting binary to decimal. Now we're going to go ahead and reverse the equation. And as you can see at the very top here, we're now going to be converting from decimal, again, if we were looking at an IP address with decimal numbers, and we're going to convert that number to binary. All right, well, that's going to do it for this video. Thanks for watching, and I hope to see you in the next video.